kids! Welcome to another session of Learning Mathematics. I am Ma'am Aika, and I am your grade 10 mathematics teacher. For this video, we will learn about combinations. This is Q3, Quarter 3 of grade 10 mathematics. Before that, let's have first the objectives. It is to illustrate the combination of objects. And I know you're excited to learn more about combinations. But before that, let's have first a review. Remember permutation? It refers to the different possible arrangements of set of objects where order matters. With this in mind, I want you to answer our review activity. Thumbs up if the situation shows that the order matters, or thumbs down if the situation shows that the order does not matter. Ready? Let's have our first situation. Choosing 5 questions to answer out of 10 questions in a test. Thumbs up, order matters, or thumbs down, order does not matter. And the answer is, good job. It's thumbs down. It doesn't matter what number you have chosen first. Let's try situation 2. Opening a numerical lock. Is this thumbs up, order matters, or thumbs down, order doesn't matter? And the answer is, very good. It's thumbs up. The order of the numbers you have to put on that numerical lock is important. Let's try situation number 3. Forming triangles from 6 distinct points in which no 3 points are collinear. Is it thumbs up, order matters, or thumbs down, order doesn't matter? And the correct answer is thumbs down. Order doesn't matter. Remember, in naming triangles, we just have to use 3 points. But as you can see here, triangle ABD, triangle BDA, and triangle DAB are equivalent. We just have one triangle with different names. Therefore, the points do not matter. Let's have situation number 4. Entering a 6-digit cellular phone password. Is it thumbs up, order does matter, or thumbs down, order does not matter? And the correct answer is, very good, it's thumbs up. You cannot unlock your phone if you have a wrong arrangement of digits. Did you get 4 out of 4 mathletes? Wow! Ay kahusay, mathletes! You are doing great! Now let's have this example. Suppose you are working in a restaurant, but because of the pandemic, there are limited seats available for dine-in patrons. If there are 3 different guests waiting to be seated, in how many ways can the 3 guests be selected 2 at a time? So we have here your restaurant, and we can only select 2 at a time. So for the first one, we can actually get guest 1 and guest 2. However, we could also interchange their arrangement, guest 2, guest 1. Also, it could be guest 1 and guest 3. But we could also rearrange them as guest 3 and guest 1. And lastly, it could be guest 2 and guest 3. And rearrange as guest 3 and guest 2. Among all this, we can actually have 6 groups for them. Group 1, possible arrangement is that we have guest 1 and guest 2. That's our first outcome. For the second group, it could be guest 1 and guest 3. And that's another outcome. For group 3, it could be guess 2 and guess 3. Another outcome. However, for group 4, if I have chosen guest 2 and guest 1, the outcome will not be counted because they are the same people seated on group 1, right? They are just rearranged. Also for group 5, it could be guest 3 and guest 1. However, we will not be counting this because it's just the same for the group 2, wherein you have guest 1 and guest 3. They are just rearranged. For group 6, we have guest 3 and guest 2. However, we will also not count this outcome because this is just the same with group 3, wherein we have picked guest 2 and guest 3. So all in all, we have here 3 ways to select guest 2 at a time. As you can see, their order does not matter. If permutation refers to the different possible arrangement of set of objects where order matters, then we have here the combination. Combination refers to the number of ways of selecting from a set when the order or arrangement is not important. So that example number 1 tells us that it is a combination problem. It doesn't matter where they are seated. To further understand, let's have another example. Example 2. Out of 4 volunteer students, Miss Sabado needs to choose 2 students to represent the school in a webinar. List down all the possible choices. So in this case, we will just be matching them up to get 2 students. So let's just name them students A, B, C, and D. So for our choice 1, it could be students A and B. Choice 2, it could be students A and C. You could also have choice 3, students A and D. Or choice 4, students B and C. But it could also be choice number 5, students B and D. Or it could be choice 6, students C and D. Again, their order or arrangement doesn't matter. So we only have here 6 possible ways to select 2 out of 4 students to attend a webinar. Now let's have example 3. A group of teacher broadcasters are going to Baguio City as part of the production of their episodes. One teacher broadcaster suggested some nice places to visit, such as A. Tamawan Village. Here, we can learn more about the region's indigenous art forms. B. Burnham Park. It is one of the top attractions in Baguio, which was named after Daniel Burnham, an American architect who was the city planner for Baguio. C. Estobosa Hillside Homes. It is inspired by the favelas of Rio de Janeiro in Brazil and the Gamcheon Cultural Village of South Korea. The question is, how many ways can the group of teacher broadcasters select 2 out of the 3 mentioned places? You can list it down, you can use your pen and paper, and let's identify how many possible choices that they can select 2 out of 3 mentioned places. Let's see the answer. For our choice 1, they could actually choose Tamawan Village and Burnham Park. Choice 2 would be Tamawan Village and Stobosa Hillside Homes. Or it could be choice 3, Burnham Park and Stobosa Hillside Homes. As you can see, we were able to enumerate all the possible outcomes. Let's review. Combination is the number of ways of selecting from a set when the order or arrangement is not important. I want you again to use your fingers to check whether the situation shows permutation, thumbs up, or combination, finger heart. Thumbs up, permutation, finger heart, combination. Are you ready? Let's do this, mathletes. Situation 1. Awarding gold, silver, and bronze medals from 10 contestants. Is it thumbs up? It shows permutation. Or finger heart? It shows combination. And the answer is very good. It's a thumbs up because the order here is important. It is important who will get the gold, the silver, and bronze. Let's try situation 2. How about drawing a set of 6 numbers in a lottery containing numbers from 1 to 45? Is it thumbs up, shows permutation, or finger heart, shows combination? And the correct answer is yes, that's right, finger heart. So when we draw a number, it doesn't matter which one goes first. For as long as you completed all the 6 numbers correctly, you'll be able to win the lottery. How about situation 3? Entering the PIN, personal identification number, of your ATM card. Is it thumbs up, shows permutation, or finger heart, shows combination? The correct answer is good job. The situation shows permutation. You will not be able to open your ATM card if you have wrong PIN, wrong arrangement of your PIN. So far, are you getting 3 points already? Doing great. Now let's go to situation 4. How about selecting 3 posters to hang on your wall out of 6 different posters? Thumbs up, permutation, or finger heart, combination? The correct answer is very good. It's a finger heart combination because you just have to simply select 3 posters. It doesn't matter what poster will be on the left, on the right, or in the middle, right? Wow. And let's go to the 5th situation. How about assigning seats in a classroom? Is the order of seats important? Is it permutation? Or is it combination? Very good. It should be permutation because once you have assigned seat, it means it's yours. You cannot interchange with a classmate. Okay? So 5 out of 5. Ay kagaling, mathletes! I hope you are doing great and enjoying our video. Now for this situation, I want you to focus. You are asked to form different triangles out of 4 distinct points, A, B, C, and D, in which no 3 points are collinear. How many different triangles can be formed? Take note that if you have triangle ABC, this is just equivalent to triangle BAC and also equivalent to triangle CBA. Also, triangle BCD is equivalent to triangle CBD, is also equivalent to triangle DBC. So, take note that we need to have unique triangles. We could have these different arrangements: ABC, ACB, BCA, BAC, CAB, CBA, ABD, ADB, BDA, BAD, DBA, DAB, BCD, BDC, CDB, CBD, DBC, DCD, CDA, CAD, DAC, DCA, ADC, and ACD. Wow, that was a lot. There are 24 arrangements. Remember, you are asked to form different triangles out of four distinct plotted points. And as we notice, there can only be four different triangles that can be formed out of four distinct plotted points, of which no 3 points are collinear. Going back to our listed arrangements, as you can see here, each column could only be having one unique triangle. So out of 24 arrangements, only 4 are possible unique triangles. And how can we solve for this without identifying all the possible outcomes? Remember your permutation where order does matter. So for you to be able to get the arrangements, we simply have to identify your n, which is 4, and r, 3. Substitute it to the formula n factorial over the quantity n minus r factorial. We have permutation of 4 objects taken 3 at a time is equal to 4 factorial over quantity 4 minus 3 factorial. This gives us 4 factorial over 1 factorial, or simply 4 factorial. 4 times 3 times 2 times 1 is equal to 24 possibilities. But this is not yet the answer, okay? Since we have there 6 more arrangements in one unique triangle, we will be dividing the permutation by 6. And take note, 6 can be written in a factorial notation, 3 factorial. That's 3 times 2 times 1. So, this one, permutation over 3 factorial, could also be this, n factorial over the quantity n minus r factorial divided by r factorial. Remember, r there is 3, so we could just represent it as r here. And that is how we derive the formula for combination. The combination of n objects taken r at a time is equal to n factorial divided by r factorial times the quantity n minus r factorial. Take note, n must be greater than or equal to r, and r must be greater than or equal to 0. Combination can be written in 3 ways. It could be this, something that looks like your permutation. It could also be this. This is more familiar if you are using your scientific calculator. Or this one. In tertiary levels, they are also using this notation for combination. But for our discussion, we will be using this. The formula for combination is combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial. Remember that we have r factorial on the denominator for combination. So, let's use the formula and solve for this example. Example 1. Find the value of combination of 5 objects taken 2 at a time using the combination formula. So if you want to try it on your paper, please do so. If not, you can listen with me and let's check the solution. So combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial. Our n is equal to 5 and r is equal to 2. Substitute to the formula, you have 5 factorial over 2 factorial times the quantity 5 minus 2 factorial. Solving, we have 5 factorial over 2 factorial times 3 factorial. So now it looks like the permutation that we discussed earlier. But then, just continue solving. And we have here 5 times 4 times 3 factorial divided by 2 times 1 times 3 factorial. Simplifying, you will have here 5 times 2. Therefore, the answer is 10. The combination of 5 objects taken 2 at a time is 10. Let's try another example. What about this? Find the value of R in combination of 6 objects taken R at a time is equal to 20. To solve, we can actually use our formula and substitute what is the given. We know that the value of combination is 20 and n is equal to 6. So from the formula, combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial. We now have 20 equals 6 factorial over r factorial times the quantity 6 minus r factorial. In this case, we will be cross multiplying, as you can see here. So we cross multiply this. That's why we now have here the r factorial times the quantity 6 minus r factorial. However, we have to divide both by 20 so that we have 6 factorial over 20 factorial on this side. Solving, you will now have here the expanded version of 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, divided by 5 times 4 as factors of your 20. So you can actually cancel 5 times 4 there and 5 times 4 on the denominator. And you will actually have your 6 times 3 times 2 times 1. Diba? 3 times 2 times 1 is actually a factorial notation of 3. So this could be written as 6 times 3 factorial. Now, we have here r factorial times the quantity 6 minus r factorial is equal to 6 times 3 factorial. But take note, 6 can also be written in factorial notation 3 factorial. So replacing, you will now have your 3 factorial, 3 factorial. And since you have 2 factorials here, note that the value of r represents one of the factorials, and that is 3. Okay? So you have an answer of 3. Next, let's have another example. How about this kind of problem? Find the value of n in combination of n objects taken 4 at a time is equal to 35. Now we have to look for n. Well, to do this, we could actually use our formula again, but this time n is unknown. But we know r is equal to 4 and the combination is 35. So from the formula, combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial. It becomes 35 equals n factorial over 4 factorial times the quantity n minus 4 factorial. Given the n factorial and n minus 4 factorial on the numerator and denominator, we could actually expand. So we have on the numerator n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial. I have to stop there because there is quantity n minus 4 factorial on the denominator. So we can simply cancel them out. And of course, 4 factorial is equal to 4 times 3 times 2 times 1. In this case, we now have 35 is equal to n times n minus 1 times n minus 2 times n minus 3 all over 24. So let's continue solving. 35 times 24 is actually equal to 840. But since we have this equation, instead of multiplying these binomials with n, we can actually find a shortcut. Remember, r is equal to 4. Therefore, we have to think of 4 consecutive numbers that when we multiply together, the answer is 840. And that gives us 7 times 6 times 5 times 4. And get the highest number among all. Therefore, your n is equal to 7. Before we end our video, let's have first a knowledge check. I will give you 5 seconds to answer each problem. But don't worry, there are choices for you to choose from. I hope you are ready, and let's start. 1. It is the arrangement of objects where order does not matter. Is it permutation or combination? Go. Did you answer combination? Good job. Remember, if the order does not matter, it's combination. Let's try number 2. The combination of n objects taken r at a time is it permutation of n objects taken r at a time equals n factorial over the quantity n minus r factorial? Or combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial? Go. Did you answer this one? Great. So take note, combination C, permutation P. And for the combination, reminder that there is this r factorial on the denominator. Now let's try this third question, the final question for this video. What about the combination of 100 objects taken 100 at a time? Is it 100 or 1? Go. Did you answer 1? Wow, that's so great. Very good, mathletes. Remember that if you have 100 objects and we want to take them all, there is only one possible arrangement for that. And correct. When n is equal to r, the answer is 1 for combination. Wow, that was amazing, mathletes. Ay ka, galing naman. Wow, time was so fast. Learning mathematics was indeed fun if you have people to talk to about it. And I wanted you to always remember that in learning mathematics, ay ka, yako, ay ka, yamo, ay ka, yan natin to. See you in our next videos, mathletes. Take care.